Previously, we created a node spawner and that spawns SDF models for gazebo simulation. What we required was to create a system that is automatically going to call the spawner node after some intervals, so our traffic light would make some sense, right? For that, we are going to create a bash file. What is a bash file and what does it do? So bash file is a file that can execute commands and do a lot of stuff, but main purpose is a bash file can execute multiple commands that we write in terminal, and that's what we want. We want the system to execute running of the spawner node after some intervals. So let's take a look. In the scripts folder that I have created, we have this light spawner.bash. Now, the light spawner.bash is basically a bash file which first saves the addresses into our variables, which can be utilized in this nodes, which can be utilized in the further lines or in the bash script. Now, after these variables are stored, if I comment these out and if I go into this folder, which is scripts, I open up my terminal and let me write something, echo, and echo just bookmark. Okay, I'm going to run this bash file, which is light spawner.bash. Press enter. It says permission denied, permission denied, permission denied. Although I did nothing, the permission is denied and command is printed. Or I could write echo my course SDC. Simply I'm running the echo command, which means prints. So basically this is a line by line execution of commands I can write in the terminal. How? If I write echo lookman, it prints lookman. If I say echo my course SDC, it writes that. So bash is basically containing the commands that we can write in terminal. So if you take a look here, I'm going to remove this. This line is actually ROS2 run pre-SDC package, the name of the node you want to execute, the path of the file, and the name after you call the SDF in the gazebo. So this makes your life very easy. And the purpose is when red light is called, we provide a 7.5 seconds of delay. Then we call the yellow light, we call 1 second delay, and then we call the green light. So this is going to make delayed calls to the spawner, and things will be very interesting. Let's take a look. We are going to make it first by calling build, and it's saved. But we have to perform one interesting thing, and this is adding this line. We actually wrote a bash script, but we want it to be executed like a node. Okay, although it is going to call multiple nodes, but we want the bash to itself run as a node. We have to bring this bash file into a specific folder, which is lib in the share of your workspace with the name of the package. If I open it, home, this self-driving workspace, install, and in install we have the share package where all of our things are available, launch, worlds, and all of the stuff. We have this lib package beside the share package in which we have our package name and all of the executable nodes as well. Although you did not do anything for bringing them here, right? They automatically got called through these lines. Okay, now this is the power of utilizing this Python-based ROS2 ecosystem. It's awesome. It makes your files move into your share folders of your workspace. Now this after call build has been pasted here, and we can run it as an executable node. So it's now time to run this bash file, right? ROS2 run previous and light spawner. Let's run it. It says permission denied. Okay, we have this simulation going on, but it says permission denied. What is the problem? And list index out of array. Okay, the problem here is when you're writing your bash script, you must be very critical with the spaces of your code. So we have to remove all the spaces. They can cause a lot of problems, and save it. Call can build it because it is going to update the file and it is required. Now let's run it. So it says something has been spawned. Let's see. Red light has been spawned. What is the other thing? The other thing is going to be spawned after 7.5 seconds. The next one is going to be spawned after 1 second. So you can see we have a traffic light and a traffic stand with traffic lights. They are working very nice. Red, yellow, and green, green, yellow, and red. This is the order. To some extent, it has been followed. And you can see things are working fine. Or my traffic stand is dynamic now. Let's close it. And now all of the things are ready. Now what we are left with, creating the whole world with all of these models and bring all of these strategies for the computer vision team to solve. Okay, let's take a look.